SpaceX's Crew Dragon fired its 8 Super Draco engines in unison at 9 a.m. Eastern and leapt off a specially built platform at Cape Canaveral Air Force Station's Space Launch Complex 40 on May 6.
4, 3, 2, 1.
Launch.
And we have ignition. The Super Dracos have ignited and are pushing the Crew Dragon off the pad.
The engines fired for about 6 seconds, instantly producing about 15,000 pounds of thrust each and lifting the spacecraft over the Atlantic before jettisoning its trunk as planned and parachuting safely into the ocean. The flight test was unlike any seen in Florida.
It's innovative, and that's really part of the whole reason we're doing Commercial Crew.
SpaceX controllers will pore over the telemetry and other data recorded during the flight test to evaluate the launch abort system and Super Draco engines.
I'm pretty sure when we get it back, there's going to be lots of data analysis, lots of cool pictures and new data for that at the end of the day is the point of the test, right? Like we collect data, we see how it goes.
NASA's Commercial Crew Program experts also will help evaluate the results as the development of one of the new generation of American spacecraft continues on pace.
If you believe in the future where 2, 3, 4 generations from now, our kids, grandkids, great-grandkids go to a spaceport the way you and I go to a airport right now, and they get on a rocket to go fly somewhere in the solar system or hopefully beyond, the DNA of that private sector capability will be in what we are doing in the Commercial Crew program.
Hi, I'm Marissa Hines, one of Curiosity's rover planners, and this is your Curiosity Rover Report. Imagine you're about to take a road trip, and you want to travel from, let's say, Atlanta, Georgia to Los Angeles, and you have a week to get there. Well, you have to decide what roads you want to take and what stops you might make along the way. What things are most important for you to visit? Curiosity has a similar situation. Here is a zoomed-out picture of where we are at Gale Crater. Pahrump Hills is up here at the top of the map, and eventually we have to cross over the Bagnall Dunes at this area and get across to the clay and hematite ridge that we want to study at the base of Mount Sharp. One of my jobs as part of the Strategic Route Planning Group is to use the orbital data that we have available to help find routes that are safe for Curiosity to traverse and allow the scientists to visit the things they find interesting. From there, the Strategic Route Planning Group developed a series of routes that we could review to find what we thought the best routes were through the corridor. On the highway map, you can see 2 different colors of routes. The white routes are the routes that the strategic group believes are the best for Curiosity's wheels. The black routes provide other options that allow the science team to get into more rugged terrain that we still think is safe and traversable for the rover. The science team decided after exiting Pahrump that the next place they really wanted to go was Logan Pass. So that allowed us to take the white route that we've now called the Lewis and Clark Trail. This red dot on the map represents our first opportunity to get a really good view of the southern region, so we stopped to take a really nice mass cam mosaic of that area. What makes Logan Pass really interesting is apparent in this mass cam image. You can see 2 distinct layers that come in contact with one another here at Logan Pass. The bottom layer being the Murray Formation, and the top layer being what we've called washboard that's been identified from the orbital imagery. After spending some time studying Logan Pass, Curiosity will get back on the Lewis and Clark Trail and head on down the road to its next destination. This has been your Curiosity Rover Report. Check back for more updates.
Welcome to Space to Ground, your weekly look at what's happening on board the International Space Station. I'm Dan Hewitt. A cargo delivery scheduled to arrive at the station this week has been canceled. The Russian Progress 59 cargo craft lifted off successfully from Kazakhstan on Tuesday, but the unmanned vehicle experienced control issues shortly after separation from the rocket. Russian flight controllers attempted to troubleshoot over the next day, but ultimately informed the crew on Wednesday that it would not be making it to the station.
The important thing is hardware can be replaced, and we'll replace all that hardware, and we'll continue to operate the space station.
Phase 2 of an exciting technology demonstration is about to begin on board. The next round of the robotic refueling mission is gearing up to demonstrate techniques that could prolong the life of satellites in Earth orbit. Using the capabilities of the Dexter robot attached to Canadarm2, robotics controllers will use new tools and techniques that could eventually give satellite owners novel ways to diagnose problems on orbit and fix issues to keep spacecraft functioning longer in space. This week, Daniela asked, if I'm a scientist, can I go to the space station? Well, a lot of astronauts have a science background, so being a scientist is a great way to join them. Just in case that doesn't work out, though, getting your research to the station is the next best thing. There are a number of ways to get experiments flown in space, whether it's through NASA, the national lab managed by our friends at CASIS, or one of our international partners. It's never been easier to get your research on board station. Head over to nasa.gov/ISS Science to learn more. Make sure to keep sending your questions and comments using the hashtag #SpaceToGround. We'll see you next week.
What's up for May? Inner planets Venus and Mercury, then Jupiter, and Saturn with wide open rings. Hello and welcome. I'm Jane Houston Jones from NASA's Jet Propulsion Laboratory in Pasadena, California. This month, Venus and Mercury grace the west-northwest sky an hour past sunset. Elusive Mercury should be visible a little less than 10 degrees above the horizon early in the month. You can measure 10 degrees by holding your outstretched, clenched fist against the sky. Bright Venus is easy to see another 20 degrees above Mercury. The giant planets Jupiter and Saturn rule the sky this month. Jupiter, the largest and brightest of our solar system's planets, has been visible for many months. If you haven't looked at Jupiter through a telescope, you're in for a real treat. Look west-northwest again and you'll find Jupiter to the upper left of bright Venus. The moon passes from right to left below the two from May 20th through the 24th. You'll get great views of Jupiter's colorful cloud bands and its 4 largest moons discovered over 400 years ago by Galileo. You can see both the cloud bands and the moons using most binoculars and telescopes of any size. NASA's Juno spacecraft, which launched August 11, 2011, has traveled over 1.5 billion miles and has another 200 million miles to go before entering Jupiter orbit on July 4, 2016. Saturn reaches opposition on May 22nd, when the planet is visible all night long. It rises at sunset in the southeast and sets at dawn in the northwest. This year, the majestic rings are open, which means they're tilted towards Earth more than 24 degrees compared to the edgewise view we had in 2009. Through a telescope, you may be able to see color differences and faint bands the color of cream and butterscotch. NASA's Cassini spacecraft, in orbit around Saturn since 2004, has 4 close encounters with Titan, 2 with Dione, and 3 with the geyser-spewing moon Enceladus this year. And in 2016 and 17, Cassini will fly up and over the north and south poles of Saturn and dive in between the innermost of the planet's rings, the D ring, and the upper atmosphere of Saturn itself. You can learn all about the Cassini mission at saturn.nasa.gov, and you can learn about all of NASA's missions, including Juno, at www.nasa.gov. That's all for this month. I'm Jane Houston Jones.